Let's jump right into this explainer. July 27th. Now, you might glance at that on your calendar and think, okay, just another summer day, but actually, it's kind of a hidden golden date in the history of math. Let's look at why.
Because on this one exact date, stretching across entirely different centuries and continents, four brilliant minds made breakthroughs that literally built the modern world we live in today. It's like a crazy mathematical coincidence.
So think about the sheer volume of private messages you send every single day. I mean, it's honestly a miracle they stay completely secure from hackers while bouncing around the open internet, right? Well, the secret to all that everyday privacy actually ties back to July 27th, 2015. That's the day we lost a brilliant mathematician named J.W.S. Cassels. Now, during World War II, Cassels worked at the legendary Bletchley Park. And what he did was use mathematical probability to strip away all this random noise that was hiding secret Japanese naval codes. Fast forward a few decades, and we're literally using that exact same mathematical logic to encrypt our digital lives. It's what keeps your personal data totally locked down today. It is just wild to think about. The high-stakes math that helped win a world war? Yeah, that's the exact same math protecting your group chats right now. Absolutely crucial stuff. All right, moving on, but sticking to July 27th. To find our next hidden architect, we have to jump way back to the year 1867. You know how today we just completely take for granted that the processors in our smartphones and gaming consoles can crunch massive, complex numbers in, like, milliseconds? Well, the absolute blueprint for that mind-bending speed was born on, you guessed it, July 27th, 1867, with a guy named Derrick Norman Lehmer. Long before silicon microchips were even a pipe dream, Lehmer built a mechanical computer. Just picture this for a second. A machine using 30 spinning gears and a beam of photoelectric light, all designed to factor massive numbers instantly. I mean, he literally built the foundation for the high-speed automated calculations that our entire tech world relies on today. So basically, his spinning gears and light beams, they're the great-grandparents of modern computing. He figured out how to turn actual electricity and light into mathematics. A real game changer. Okay, let's fast forward over a century later. It's July 27th, 1999, and we run into a completely different kind of mathematical mystery. If you've ever really looked closely at your favorite 3D video games or, say, VR worlds, you probably realize those super realistic environments are actually just stitched together from flat geometric shapes. Well, the pioneer who really helped make that illusion possible was a mathematician named Aleksandr Aleksandrov, and he passed away on July 27, 1999. He constructed this massive, overarching theory mapping out the intrinsic geometry of convex surfaces. He basically pushed the boundaries of how we even understand 3D shapes. Today, modern software engines rely heavily on his abstract geometry to quickly render the lighting, the angles, and all those 3D graphics we interact with on our flat screens. It's just such a beautiful realization, really. Purely abstract, academic geometry serving as the invisible framework holding up literally every single virtual universe we explore. Which brings us to our final stop on this very specific timeline, July 27th, 2021. You know, behind all this incredible software, hardware, and encryption, there has to be a robust education system, right? Something capable of actually training the next generation of innovators. And that right there was the lifelong mission of Enrique Planchart, whom we sadly lost on July 27th, 2021. Planchart spent his life traveling from school to school, just actively hunting for young talent. He thought tirelessly to modernize math and science programs. He knew, for sure, that for any society to really thrive in the digital age, it had to put knowledge and education first. He understood something totally fundamental that ties all these pioneers together. Education is basically the operating system of the future. So, looking back at this, every single pioneer we met in this explainer today, across entirely different centuries and cultures, they were all ultimately driven by the exact same question. What is the pattern hiding inside the chaos? And honestly, because they were so obsessed with finding those patterns, our world today enjoys totally secure communication, lightning-fast computing, boundless 3D worlds, and the universities to actually teach all of it. Which leaves us with one final thought here. Just look around you. The chaos is still out there, right? It's just waiting to be solved. So what hidden pattern will you discover to change tomorrow's world?